This is part of the series of full stack development where 3 videos we covered React, 3 videos we covered Node. So we covered the presentation layer and then the service layer. Now it's time to talk about the data layer of the 3-tier architecture for full stack JavaScript development. This is where we're going to cover MongoDB as the database chosen for this 3-tier architecture. And this is what's used in the Newswatcher application, which we'll get to later. Let's start off then just by discussing the options that are available for databases. Many different databases have been invented over the years. This is just a partial list. There's relational databases, the most famous one being Microsoft SQL Server or Oracle. Then there were hierarchical index databases, key value that just are very simple. They store a key and then a lookup to get the value. Document-based, which is what we're going to focus on this video. Object-oriented became a big thing in programming. People thought it would be useful in a database as well. There are graph databases that have the ability to really connect and relate data in a structure that allows you to find out relationships that may not normally be apparent and easy to get at in other databases. And then there's NoSQL, which is kind of a general category, right? There's SQL databases and NoSQL, meaning that some of them can be queried with the SQL syntax. They're normalized versus a NoSQL database, which a good example is a document-based database, which is denormalized. Anyway, you look at all those different databases and they were invented for different purposes. They could be more efficient than others for some reason, or easier to access the data, or you get the data back in a different form that's more convenient to be used. And this is a good point of why I like document-based databases, because you're using a document to transfer data and store it in your code in variables like objects, and then that can be transferred directly into the database like in JSON form. Fundamentally though, all databases need to support the basics of data storage, transactions, meaning you can make sure something actually happens. If you need to update multiple things in a database, you can transact that. So if part of it fails, you can roll it back. And then just briefly, some of the other ones, you have to have authorization, obviously accessing the database. Indexing is important because it helps speed up access to the data. And so that's usually available on all databases. You have to have things that are secure. And some databases offer programmability that's right in the database itself. That allows you to perform operations more efficiently. Even though, things like stored procedures in SQL are kind of frowned upon today. It used to be that people would write thousands of stored procedures in their applications. Today, it's more recommended if you're using a SQL Server to only use them for CRUD operations, create, read, update, and delete. And then some of the other things that we could talk about, the final thing I guess I'll pick out on this is the schematization. Obviously, with a database like a SQL Server, which is a relational database, you actually have a schema, right? You predetermine and create from a script all the table structures and give very specifics about what each column in a table can contain. It can contain a varchar or a number or a binary, things like that. And this will be something we'll talk about then with document-based databases and MongoDB in particular, because it kind of tries to, well, it doesn't kind of, it gets away from that, where you don't really have to provide a schema. Now, I say kind of because they did add that in at a later time, that you can still provide a schema, but it's not necessary. And the last thing I want to say is that with AWS, they have several different offerings, many different offerings, and I just list a few here that are useful in the cloud as platform as a service. You can obviously rent EC2 instances and you can install any database you want and manage it, but I highly recommend always to anyone architecting a system to really go with platform as a service. So there's DynamoDB, which is basically that key value store, but it can also store documents. It's very fast, like millisecond access time, incredibly scalable and serverless. Then there's RDS, Aurora. So Aurora is, let me just talk about RDS first. So there's several different databases supported in Aurora. MariaDB, Postgres, MySQL, SQL Server, Oracle. And with these databases, right, they're platform as a service. And there's the ability to set up replication and read instances and all that kind of thing. The Aurora version of it is where AWS took MySQL and Postgres, and they made their own versions of that. They took the code and they optimized it, so it's kind of enhanced. Then there's other things like Redshift and S3, which are more for storing like data warehouse and data lake type storage. So I wouldn't really say S3 is a database, but you still can query across it. There's a capability to basically look at things at S3 and actually query across S3. Then finally, some other things we can mention about what they offer is the DocumentDB version in AWS. So that's where they took MongoDB and they hosted it in a PaaS environment and call it DocumentDB. So what is MongoDB? It's classified as NoSQL. In other words, you don't use SQL statements to query it. There's a special syntax that we'll get at where you have projection and query criteria. It's non-relational, meaning it's not schematized, so that you don't need to have, so we'll get into this in more detail, but you put documents basically like JSON, and you can put any JSON document into MongoDB that you want. And so it's kind of free form. There's no central catalog or anything like referential integrity or anything like that you see in a normalized relational database. And then, so they can be free form, as I mentioned. And then it's stored, I mentioned it's stored in JSON, but it's actually a binary version of that called BSON. And it gives you a little bit more capability because there's more data types in the BSON than there is actually in the JSON if you need to go outside of that. It gives great scaling and performance. There's the ability to have high availability and reliability with the way that it's clustered with the primary and secondary machines, and we'll get into that. It's purchased as a platform as a service, even though you can run it on your own. As I mentioned, there is a version in AWS called DocumentDB that they host. There's also the MongoDB Inc. company itself that has what they call Atlas. And Atlas is a service that you can get PaaS from. And they host actually in Google or Azure and AWS. I use them out of AWS. This image depicts the actual structure of what you get in MongoDB. The cluster is the group of machines that are set up to host your databases. So you can have multiple databases in a cluster. So you have this cluster, which consists of a primary machine and secondary for failover, and then you create databases. So once a cluster is set up in Atlas, then you can create or delete databases. And databases have users which have permissions. So that means a user can log into Atlas and can read what are in the documents, or maybe they have full capability like admin to read and write and to delete and all that kind of thing. A user can also be set up more or less as a code access, and then your code can access the database as well. Each database then can have multiple collections. So there's multiple databases with multiple collections, and then a collection then is just this concept of holding documents. Now, documents then are basically the JSON. So if we look at what that is, we can see just on the screen this simple depiction of JSON, even though it's stored in BSON, which is the binary version. So we have collection 1 and collection 2. Each of these has a document in it, and there's the dots over here just represent that there's multiple documents in this collection. Now these documents look unified. In other words, they look the same. They each have the same properties, keys and values, but really they don't have to. They can be completely different. They don't have to have anything the same. So the nice thing is you can have multiple types of documents, and you could actually give it a, and we'll see this later, you could give it a property of type, and then to query you would just look it up by that type. Or maybe you would just create a second collection, and then you'd have different types of documents in that other collection. Let's dive into some of the details then of the JSON representation of what a document would look like. It's no different than the JSON you see. It's standard, nothing unusual here. And as we mentioned, this is a non-relational database, a non-SQL database, NoSQL. That means it's denormalized. If you look at this document, this represents a customer. So let's pretend here for the scenario, you've got a bookstore and you have customers and the customers order books online. Now, everything is in this one single document, whereas with a relational document, you would split things out. So you might have the customer document, which may just contain the name, age, email, and address, but it wouldn't contain the books they purchased. That would be in a different table, and that would have a key to look it up. So that the ID here for the customer would also exist in the books purchased table. And then you could look up by Joe Schmo ID 77 all the books that he has purchased. But here it's denormalized, so we bring all the books into his single document. And you can see it's hierarchical, right, like JSON is, and you can have arrays and whatnot. So it works pretty well to represent any types of data you want. And you can have dates in here or numbers or strings. We had the orders with the person, with the customer. But we might want to separate out the books that they could actually purchase. Obviously we would, because let's say we have 100,000 books that they could order. That wouldn't be good to store in each document and then have a checkbox or a flag if they had ordered that book or not. Instead, we want to have them separately. So we would separate out into book documents. So these are, here's the comma. Each one of these represents a separate document. So this isn't one document. This is separate documents here. And they're of type book. So we have the title, and we have the ISBN, we have the author, pages, anything we needed. There could be a lot more information in here. We might want a cost in here as well. Now, here's a silly little illustration. I took some clip art here. This illustrates what a normalized view would be of data versus denormalized. In this case, let's say we're a veterinarian and we're keeping track of our customers that have their pets. And they might have separate records for the person and then a record for the pet. Because the pet, right, has a name, they have an age, they have a weight, they have a list of prescriptions or medical procedures that have been performed on that, when their last visit was, all that kind of thing. So that shows how that's split out. And there's links, like we said. So you have, keys to find the pets that belong to an owner. And of course, denormalized then, here's our person here with all the pets in his pocket. So they all go together. It's all in one document. How can we make some kind of a compromise then? You saw earlier where we stored a lot of the details about a book in the books purchased array for each customer. Instead of doing that, we can kind of create a hybrid here. So we only need to really store the ISBN number and the title. So when you go to a customer, they could see the titles that they purchased, but they don't need to see the details, right? They don't need to know the author or how many pages or anything like that. Then if they did want to click on a book, and maybe on the right-hand side of the UI show the details, then that's when we could fetch that particular ISBN number and get it. And we, of course, can create an index on that so it's very quick to look up. So here's a look at that, right? We have the books purchased, and we have the titles and ISBN numbers. And then here's a little bit of a blow-up. I've added book reviews, which is another, again, idea of Do we keep book reviews with the book? Seems like it might be a good idea. There's really no reason to split that out. And here we have, right, the Agile Project Management book that has reviews, but the other one doesn't have any. Just because I mentioned that we're using MongoDB, a document-based database, and it's kind of free form, well, you saw that we do have a structure, right? So we predetermined what our structure should look like for each of our documents. And we'll actually enforce that. So if you go back to the Node series of videos, you'll see that we use something called joy in the Node backend. So when our documents come in, we actually do have, that's kind of where we enforce the schema then, right? So the JSON comes in and it has to have like required properties and optional ones. And if any new ones come in there, it will get rejected, right? So that's kind of where we enforce that. And it's basically one central place. There is actually the capability in MongoDB, but I'm not going to cover it in our video series here. You can look it up, but you can create a schema and then determine what you want up front. The point is, though, you can do this on paper, and you should, or you can use, some kind of charting software to really put it together. So that's what I've done here, where I've shown, here's a structure, and I need to have these relationships between my documents. We'll get into what the news watcher looks like, but this is kind of a generic look at how you might put together relationships between documents. So you have a customer document and you can split out customer addresses. So you need to do your data modeling. And so I'm showing one-to-one relationships here. Each customer only has one address. So here's the case where there's one book and there are many customers. So many customers reference this one single book. Then there's the many-to-many association. And this is the case, again, where we may do it a little bit differently. We take the same scenario here where we have customers purchasing books. What we could do instead is we could have this association document. And that association document then says, okay, this is a purchase. We have a date of the purchase, we have an amount, and who purchased it is the customer, which relates to this document. And then the book is referenced here. This is a handy way to structure the relationship between documents. Just to stress the point again, and we're going to show you this in our Newswatcher database model, that if you do want to store multiple types of documents, you're going to need a type property, or type key. And so the type would be person type or pet type. This goes back to our veterinarian example. And you'd obviously want to create an index on that. This video is focusing just on the concepts of MongoDB. Some people just say Mongo for short. The point here is that there is a way to program through the SDKs that are available to get at the MongoDB database that you've got. Now, on top of the MongoDB database, this is a very typical thing to do, and you actually see this for AWS resources as well, that there is a fundamental HTTP wire protocol, TCP/IP wire protocol that you could program to. So you could make these calls with a connection directly to that. This is kind of low level and it requires a little bit more lifting. On top of that, they've built these drivers, though, that simplify your access. And then you don't have to deal with the wire protocol. And here's a list of just a few of those that are available. There's a C# driver, Java, Python, and the one that we use in our second video is the JavaScript Node driver, Node.js.